Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. In this video, we'll go through some exam questions on the topic called electricity. The first question says, explain with the aid of a circuit diagram the method a student could use to investigate how the resistance of a single lamp changes with the potential difference across the lamp. So basically what they are saying is they're saying you will change the potential difference across the lamp and you're going to work out what the value of resistance will be for that lamp. So if you remember, in my last video, I gave you a circuit. I told you you'll have to memorize that. I'll draw that circuit. I'll have variable resistor. At this location, I will now have my lamp because they've given me in question that it is lamp. Across the lamp, I'll install a voltmeter. Here I can have an ammeter and they are then connected together. This is the value of R for the variable resistor. And we know every time we change R, the value on this voltmeter will change and the value on this ammeter will change. So we are going to write down the equation. The equation is R equals V over I. To find the value of R, I'm going to call this Rx. Right? So to find the value of Rx, I will need to work out the value of potential difference across it and the current that will go through it. So basically I need two values. One value will come from here to there, and the second value will come from here to there. Once I know these two values, I can divide, and that will give me the value of R. But the question is not asking us how can we work out the value of R. The question says you have to investigate how resistance of a single lamp changes. So we have to collect data for number of readings. So in this case, I'm going to say you'll have to change R and record value on voltmeter and ammeter. Number two, I'm going to say repeat step one until you have 6 readings of V and I. Once you have that, then you can say plot graph of I against V, and in this case our resistance will be worked out by the formula 1 divided by gradient. And that will get you full 6 marks. So not a difficult question. You just have to remember every time you have to investigate the resistance of a component, you will always draw the same circuit. And you will always have this equation. And the value of V in this equation will come from the voltmeter. The value of current will come from this ammeter. But this time, because they said we have to look at it, how it changes. So we have to take data for number of readings and plot a graph. So that's why we said change R and record values on voltmeter and ammeter. Repeat step 1 until you have 6 readings for V and I, and then you plot the graph. If you calculate the gradient and if you use this equation, that will give you the value of resistance at different locations. Next question. It says an electric heater is connected to a 230 volt supply. Now this is a calculation question, so unit conversion may be required. I'll assign them with the letters. So this is the value of V. This is the value of P, but I can't use it in kilowatts, so I'll have to do a unit conversion. I'll multiply this by 1000, and this is now in watts. It says calculate the current. I don't know the value of current. I now need to write down the equation. The equation is P equals V times I. Substitute the values and solve, and you'll end up with the answer. So I can say it will be 2.6 times by 1000 equals 230 times by I. You divide both sides by 230. This is gone, leaves you with I equals something in amps. Next question. This time you've been given 2 different setups. So this one is AC because it's the supply that we have in our houses, and this is battery, so this is direct current. So this figure 19 shows 2 electrical devices for heating water. So you're using 1 and 2. Here you're using kettle, which is working on alternating current. Here using immersion heater which works on direct current. It says the current in the element of the immersion heater is 14 amps. So here the current has a value of 14 amps. The power of the immersion heater is 130 watts. So this is the value of P, the value of I. It says calculate the resistance. So R is not known. Then it also says you have to give your answer to two significant figures. So what will I do? I'll write down the equation first, which connects P, I, and R. There's only one equation, which is P equals I squared times R. You can plug the values in. The value of I is given to us as 14, so it will be 14 squared times R. On the left side, I've been given the value of power as 130. If you divide both sides by 14 squared, this will cancel out, leaving you with R being equal to 130 over 14 squared. If you plug it in your calculator, it will give you a value of R in ohms. Make sure you convert this to 2 sig fig. That would be your answer. Next question says the current in the heating element of a kettle is 8.3 amps. So what does this mean? This means in this case, the current is 8.3 amps. Say state two differences between the movement of charges in heating element of the kettle and movement of charges in the immersion heat. So we have to talk about movement. So I can see I already gave you some information here. 1, 2, 3, and 4. So I can then say first one is AC, the other one is DC. So in one, rather than saying in one, we should say immersion heater. They move in one direction. But in case of heating element, they will vibrate between positive and negative value. Next difference, we have to talk about the movement again. Here you have a bigger current, here you have a smaller current. So I can say here the movement is going to be more quicker, here the movement is going to be slower. So we can say here number 1, we can again write down immersion heater has more movement of charges. Okay, that's why. That's because it has bigger current. That's because it has bigger current. Next question. Says a technician investigates a light dependent resistor LDR. So the moment I see LDR, I need to remind myself, if light increases, then the resistance will decrease and the opposite will happen too. Connected in series with 120 ohms resistor and a voltage source. The technician measures the voltage across the LDR and also the current in the LDR. Which one of these circuits should the technician use? So I can see in this case, they were both connected incorrectly. In this case, this is connected correctly and this is also connected correctly. In the next case, this is connected correctly, this is connected incorrectly. Here it is connected correctly, this is connected incorrectly. The only option that's true is B, so my answer is B. So they are basically testing you on your understanding. Do you know how to connect voltmeter and an ammeter? So remember, voltmeter is always across the component, but the ammeter is always in series with other components. Next question says when the LDR is in bright sunlight, its resistance is 185 ohms. So this is the value of R. It says the voltage across the LDR is 7.2 volts. This is my V. Show that the current. Whenever they give you something like this, show that the current, you have to calculate that current. It says when you calculate this current, it should be close to this value or equal to. So in this case, I'll again write down the equation that has these three letters in it, which is V equals I times R. The value of V is 7.2. Current is not known. Resistance is 185. If you divide both sides by 185, this will cancel out and give you the value of I, which will be close to or equal to 0.03. Next part says complete the sentence by putting a cross in the box next to your answer. The current in 120 ohm resistor is, it's going to be same as the LDR because it's a series circuit. So the current will be same everywhere. Current is same everywhere. Next part says the photograph shows a temporary traffic sign. Traffic sign uses many small lights, all powered by a rechargeable battery. These lights need to be very bright during the day so that they can be seen clearly. They do not need to be as bright at night. Explain how the use of light-dependent resistor can make the energy stored in the battery last longer. This is similar to question number 1, but this time at this location we have LDR. So remember, here it is R. I can then say I've got ammeter, I've got voltmeter. So if I make use of this circuit, what's going to happen in this case is we can say during the daytime, so we have to show can make the energy stored in the battery last longer. It will be only possible if current decreases, then it will last longer. If the current stays bigger, then it will not be able to store energy for a longer duration of time. So we can say during the daytime, resistance will be low here. And if resistance is low, then I can say my R total will be low. R total is the sum of them two together. Resistance of this and resistance of that. Put together, that gives us the value of RT. But because this has gone down, the total resistance will fall. And if the total resistance falls, then I can say the current will be large. The potential difference across the lamp, or I can say the LEDs, will be larger and they will be bright during day. Now at night time, what will happen? Resistance will increase because the light will fall down. If resistance increases, then I can say my total value for this will increase. If that's the case, then my current will decrease. Then I can say the value of V across these lights will decrease. If it decreases, then this means they will be less bright. So I can then say, based on these two conditions, I can say during day, more energy is used. But during night time, less energy is used because current falls down. So during night time, less energy is used because current falls down. Next question. A man monitors how much money he spends on electricity. He uses a device which calculates the cost of electrical energy used. He connects his 2.9 kilowatt. Now I can't use this power. It has to be converted into watts, so I'll multiply it by 1000. He connects it to the supply, and that supply has potential difference of 230, so that's the value of V. I know the value of V and I know the value of power. It says calculate the value of the current. I'll use equation P equals V times I. I've already done the conversion. You just have to plug the values in and you'll be able to work out the answer. So you can say it will be 2.9 times by 1000 equals 230 times I. Divide both sides by 230. And if you put the left side in your calculator, it will give you the value of current in. The unit conversion is very important. Next question. The device shows that in 1 week, the total cost of electrical energy used by the kettle is 97p. So this is the total cost for 1 week. And it tells you that 1 kilowatt hour of electrical energy costs 17p. Remember, 1 kilowatt hour, this is energy. Because you're multiplying power with time. And if you multiply power with time, that gives you the value of energy. The power times time will give you the energy. It says calculate the length of time for which the kettle has been switched on during the week. So here is a formula that you need to remember. cost will be equal to power rating, it must be in kilowatts, times by time, this time has to be in hours, times by cost of 1 kilowatt. We know the values in this case because we've been given the total cost, which is 97. Power rating was given to us over here as 2.9 kilowatts, so I'm going to use 2.9 kilowatts here. I don't know the value of time, so I'll keep it as T, but the cost is given to me as 17p for each kilowatt hour. So if I multiply and solve from here, you will end up with a value of T, and this will be in hours. So to solve it, you will need to divide both sides by 2.9 times 17. 2.9 times 17. This will cancel out and this will cancel out, leaving you with this side, which can be plugged into calculator to work out the value of T. Next question says, a resistor is connected to a power supply. The potential difference across the resistor is 6 volts. So this is the value of V. Which of these corresponds to potential difference of 6 volt? So you need to recall potential difference is defined as V is equal to E over Q. It is energy gained or lost by 1 coulomb of charge when it moves between 2 points. In this case, which one has similar unit? It should be joules per coulomb. Joules per coulomb is C. So the answer is C. Next question says the resistor remains connected for a period of time. The current in the resistor is 200 milliamps. Again, I'll have to do conversion. This is the value of I, but I can't use it in this form. I'll have to change it into amps, and for that I'll have to divide it by 1000. A total charge of 42 coulombs. This is the value of Q, and it says calculate in minutes the time taken. So we need to work out the value of T in minutes. Again, I'll write down the equation, which is Q equals I times T. Plug in the numbers. This is 42. This is 200 times by divide by 1000 times by T. So we can say it will become 42 equals 0.2 times T, and from here you can work out the value of T. Remember, this will be in seconds. You will then have to convert this value into minutes. So whatever the value is here, you will divide that by 60 to work out the answer. Next question says calculate the total energy transferred. So total energy transferred, meaning E is not known. The value of V is 6 volt, is the value of Q. All we have to do is just write down the equation, which is given to you already here. You write down E equals V times Q, the value of V is 6 times 42, and you'll end up with the answer in joules. Next question. A resistor is connected to a power supply. The resistor becomes warm when there is current in it. Explain why resistor becomes warm. I did give you the answer to this in the last video as well. So you'll have to remember, when current flows, then electrons will collide with positive ions, because that's how the metal, that's what the structure of metal is like. We can say some Ke is lost as thermal energy in the resistor. Next question, it says figure 16 shows a cardboard with a wire coming out from the each end. There are two 10 ohms resistor inside the cardboard. Now there are two 10 ohms resistor. Now these two 10 ohms resistors could be in series or parallel. This is the potential difference of 6 volt. This is the value of V. Is connected between P and Q. There's a current of this, which is 1.2. Deduce how the resistors have been arranged inside the cardboard. Arranged means talking about are they in series or parallel. So we've discussed earlier, if they are in series, then the R total will increase. If they are in parallel, then my R total will decrease. Let's see. So you will work out the value of resistance using these two values. So you'll work out R equals V over I. What's the value of V? 6.0 over 1.2, and this gives us a value of 5.0 ohms. So I can see my resistance has gone down, so I can then say it is parallel because R total is lower. Next question. The technician investigates different electrical devices that are used in a car. The technician connects 4 devices to the 12-volt car battery. Each device is connected to its own switch and its own fuse. Now, recoil fuse is protective device. I have not discussed this in my last video, so you need to do this part yourself. Figure 18 shows how the 4 devices, fuses and switches are connected together. The current in each device is shown next to the device. So you've been given the value of current. I can see these 3 values are in amps, but this one is in milliamps, so I'll have to do 600 divided by 1000, and that will give me 0.6 amps. Now this is fine. It says calculate the current in the wire to the battery when all devices are switched on. It says wires to the battery. This means they're asking us to work out the total current, because when these currents will come out, it's a parallel circuit. They will all add up together. The total current will be 4.8 plus 0.6 plus 10 plus 2.3. And if you add them, that will be your total current. Next question says state how the overall resistance of the circuit changes when one of the devices is switched off. So if I switch off this device, what will happen to this current? This current will disappear. If this current disappears, now I have less current. So if there's less current, that means the resistance has gone up. So I can say current will decrease, therefore resistance will increase. Next question says there's a current of 2.3 amp in the radio when the radio is working correctly. Which of these should the technician choose to protect the radio circuit? So they've given us 4 choices for the fuses. We can't use less than 2.3, so it will not work. This is too big. The only one that will work in our case is 5 amps. Next question says explain why the wires to the battery in the car are thicker than the wires that connect each device to the switch and its fuse. So you can see here the wires to the battery, they are carrying the entire amount of current, but then this current splits up. So for these wires to carry large amount of current, they have to be thick. If these wires are thin, there will be bigger amount of energy losses in them. So we can say wires to the battery carry large current, therefore should have low R to ensure less energy is lost in the wires. Next question. Figure 21 and 22 show how different voltages can be applied across a wire. So we've been given 2 different types. Here I can see this is positive to negative and then back to positive. In this case, this is always positive. Explain which of the voltages in figure 21 and 22 can cause an AC current in the wire. The AC current will be caused by figure 21 because it fluctuates between positive, then negative, and then positive. So if this one is used for the current will be positive, negative, positive, negative, positive, negative. Here it will always remain positive, but the value will keep on decreasing, increasing. Last question on this sheet. It says a student investigates resistors connected in parallel using a number of resistors. Each resistor has the same resistance. Figure 19 shows a circuit diagram with one resistor R. Add to figure 19 a voltmeter to find the potential difference across resistor R. So I told you it says across the resistor R. So voltmeter always connected across the component. Another resistor in parallel with resistor R. Parallel means something that will be like that. State the measurements that the student must take to find overall resistance of the resistors in parallel. So you need to recall the formula. R is equal to V over I. You'll say record value of voltmeter and ammeter, and then use these values in this expression to find the value of R. That's it for this topic. Remember, I did not discuss in my last video and on this worksheet the safety features like the earth wire, fuses and things like that, right? So make sure you spend a bit of time on them before you conclude with your exam preparation. I hope you'll find this video useful. I wish you all very good luck with your exam preparation. Thank you.